Yeah. Would it be sine of 0 divided by sine of another 0?
Mm-hmm. Then what is sine of 0?
Would it be 1?
Ay, Dios mío. Are you sure?
Sine of 0. Cosine cosine is. Oh, it'd be 0. Yeah, it'd be 0. Because the coordinate for 0 is the one on the x, and then it'd be 1, 0. Yeah. 1, 0.
Cosine then sine, yes.
Yeah.
All right, so here we have 0 over 0. We write I and D. And then what?
So we'll try to simplify it so we can evaluate it.
Okay, how?
There's like the sign of 2 theta looks familiar, like the double angle theorem or something like that.
Yeah, there's a double angle theorem, but it's not gonna. No, I think it'll make it more complicated.
Okay.
Called trig limits. There's an identity that says if the boxes are the same and they approach 0, then the limit will equal 1. So what you should have done with this problem is you should have separated it into 2 limits first. Then at that point, you should have multiplied top and bottom by stuff to make this argument, this box, the same on the denominator. So in this case, there's just a 1 implied to be there, right? So if I multiply the top and the bottom by 2 theta, then I have the identity right here inside the parentheses, okay? And then I didn't change the problem because I multiplied top and bottom by the same thing. Same thing goes over here, that it would be a 4 theta, okay? Now we're going to write it in a way that we can exhibit our identities clearly, or see our identities. And we're going to have limit as theta approaches 0 of sine 2 theta over 2 theta. And then times limit as, because it doesn't matter what order you multiply in. 2 times 3 is still 3 times 2. So then when you get to this stage, you write one more limit for everything that you didn't write down so far. So what have I not written down? Well, the 2 theta from the bottom is there, but the one from the top is not there. And then the 4 theta from the top is there, but the one from the bottom is not. So we would need to include those two to have that problem remain equivalent. If we didn't have those 2 things there, we would have changed the integrity of the problem and gotten it wrong. Any questions so far?
No.
So then at this point, you can either say this goes to 1, because this should be a 0, not a theta. This goes to 1 because the box is the same on top and bottom, and both boxes go to 0. If you want to be really technical about it, you could say let t equal to theta as theta approaches 0. What does t do?
Are you asking me?
Yes. As theta approaches 0, what does t do?
It gets smaller.
Just look right here. T equals 2 theta. As theta approaches 0, what is t going to do? It's going to approach 0 as well.
Yeah.
Right? So then you could write this, rewrite it as limit as t approaches 0 of sine t over t, which is the true identity. And then you can say that goes to 1. Okay. Most professors, or graders, just say this is 1 because the arguments are the same. They'll give you full credit. Okay. Every once in a while, you get some math nerd that's mad at the world, and they'll take off for stuff like that. Now, I did forget to write the 4 theta right here. You should have caught me on that. Okay. So then at that point, this also will go to 1, and the thetas will cancel, and the limit as theta approaches 0 is 2 over 4, or 1/2. Now, usually a student will ask me, well, can I just cancel this sign and this theta and get 2 over 4? That's pure coincidence. If you don't show the work, you'll get 0 credit. Okay. Do you have any questions over this problem?
It seems harder.
Yeah, the trig ones people have a little bit more problem with. But watch the trig identity limit videos, okay? And if you practice a few of them, you'll see they're not as bad as you think. It's just overwhelming at first. The key is to try to make whatever's after your sign also be the same thing that you have on the bottom. And if you multiply the bottom by something, you have to multiply the top by the same thing. And then you can just rewrite them to where you have the identities by themselves so they can approach 1. Okay, this is just something you have to memorize. Got it?
Yes.